Good morning. So today's discussion is about paired t-test. Paired t-test is a test of significant difference, but it is from the word paired. It should be your data should have before and after. So usually this test is used by teachers to see the effectiveness of their teaching strategy. For example, the use of flashcards. So there will be a test before the intervention. They will have a pre-test and then they will do the intervention, which is the using of flashcards, and then they will again do the post-test. So paired t-test is you will use this one when it is a parametric test and if your data have met the assumption of normality and homogeneity of variance. So this one, we will run this in the JAMOVI application. So again, I have here the SPSS, the data, the JAMOVI, and then the R. But for my YouTube channel, I am very particular with the use of JAMOVI. It is a free software that you can just download in the internet, and it is a user-friendly, especially for those students or for those researchers that is new to data analysis. So today's discussion is that we will be using a data that has a before and after, a pre-test and a post-test. So here we have the data. We need to look at here. We have the respondents number. So these are students in, this is the pre-test. And I guess, I do not know the intervention of my client in this case, but they have the pre-test and the post-test. So in between of the pre-test and the post-test, maybe there is an intervention in any other subjects. So we have here that in respondent number 1, during the pre-test, he or she got 2, but during the post-test, he or she got 7. So therefore, we can conclude here that maybe we can see here that there is an increase, right? So we cannot just directly assume that there is an increase. We need to infer it using a statistical test. So again, you need to run this in the JAMOVI statistical output, I mean statistical software. So you need to click this horizontal line. After clicking the horizontal line, it will navigate you to this word import. And then you click the import and then you can see here the browse figure. So you just click the browse and it will navigate you to the folder that you are using. So in my case, I have put that in my, here, we have the paired t-test. So you need to click this one, the Excel file, and then you will have this data. But this data is not really that in the first column. So in order for this data to be in the first, second, and third column, all you need to do is to highlight the column and then delete the variables. So after deleting the variables, you need to save this output so that whatever happens, especially if your laptop is not really that good, you need to, you were able to save your project. So you will do paired t-test. It's up to you if what are you going to name your project. But for my case, since I am using this for my YouTube channel, I am saving it with the name paired t-test. So we have here the pre-test and the post-test. And since this is a test score, the level of measurement here is a ratio. So we have here the t-test. You click the taskbar, which is t-test, and we have the independent t-test, the paired t-test, and one sample t-test. For the independent sample t-test, this is used to test the significant difference of two groups. But here, the paired sample t-test, this is the test that you need to use when you want to see the difference of the data before and after an intervention. So this is the test that we are going to use. And one sample t-test, for one sample t-test is you need to test one sample if it is part of the group. So let's go to the paired sample t-test. So after clicking the paired sample t-test, it will navigate you to this task bar. I do not know what do you call this part, but we have here the student test, bias factor, Wilcoxon rank. Wilcoxon rank is used when your data does not meet the assumption. So we can do the paired variables, the pre-test here, and also the post-test here. So we can see the result of our test. So it is less than 0.05. Take note about this, that the result that you need to see is only the p-value. Now, if the p-value is less than 0.05, therefore there is a significant difference. So we can see that the p-value here is 0.001, which means that pre-test and post-test is significantly different from each other. But we cannot see which one has the highest and which one has the lowest. Before, when we check our data, the highest is the post-test, right? And the pre-test is really lower. But you need to have the significant difference. You need to see which one has the highest and which one is the lowest. But before running or using the paired t-test, you still need to check the assumption. Now, if the assumption, this is the tricky part when you test the normality of the data. Okay, so good here that the normality test, the Shapiro-Wilk, it says that here that p-value is greater than 0.212. I mean, greater than 0.05. So, we can conclude that our data, the data of this one is normally distributed. This is very tricky because in here, the paired t-test, you need to see less than 0.05 to have a significant difference. But in normality test, you need to have greater than 0.05 to see and to say that your data is normally distributed. So here is less than 0.05. So therefore, there is a significant difference between the pre-test and the post-test. But in normality test, you need to have greater than 0.05 so that you can use the paired t-test. So since this is greater than 0.05, therefore, we can use the paired t-test. Okay? Now, what if the p-value of the normality test is less than 0.05? This one, less than 0.05. Therefore, the p-value here is not, therefore, your data is not normally distributed. And you cannot use the paired sample t-test. So you need to use the Wilcoxon rank. So we have here the Wilcoxon rank. So even though we are using the Wilcoxon rank, it's still less than 0.05. So, but since it has met the assumption, you do not need to run the Wilcoxon rank. Okay? So here you have the paired sample t-test, and it passed the normality test. And we have here the hypothesis, measure 1 is not equal to measure 2, and measure 1 is greater than measure 2. So it's up to you of what kind of hypothesis you are having. But the hypothesis that we are just testing in this video is only the hypothesis that our pre-test and post-test do not differ significantly. Since we reject the null hypothesis here, therefore, pre-test and post-test differ significantly. Now, in testing the hypothesis, reject and fail to reject, I will discuss that in my other video. So we need to see the mean difference so that we will be able to see which one has the highest or which one is the lowest. So here, the mean difference is negative 4.17. But we want to see the descriptives of pretest and posttest, so we can use that in our results and discussion. So you click the descriptives. For the descriptives, it will give you a data of mean, median, and standard deviation and standard error. So this mean difference is taken by subtracting post-test from pre-test. So here we can see that mean is 6.92 is really greater than the pre-test, which is 2.75. So this is further explained that there is a significance of pre-test and post-test. Now, since there is a significant difference, you will ask, which one is greater, the pre-test or the post-test? And we can see here the pre-test and post-test, we have the mean. So the post-test has the highest score here and the pre-test has the lowest. So therefore, we can conclude that the intervention made by the researcher is effective. So for example, if your researcher have used the placards or the flashcards, therefore the intervention is effective. Why? Because the pretest, the mean score is only 2.75 and it becomes 6.92, the mean score. So there is a significant increase. Now, how do you discuss this one in your results and discussion? So I will teach you how to discuss this one in software. So this one, I have run that to the SPSS. But you as a researcher, if you are using a JAMOVI application, you need to copy and paste that on a file name statistical software. Because in this manner, whoever will look at your account or your manuscript will really say that your data has been run to a statistical output. So here we have the parity test, the normality test, and the descriptive statistics. Now, how do you discuss this one in your results and discussion? So this depends on how you will discuss this one or how your school, the pattern of your school. But usually some of the neophyte researcher, they do not know how to discuss this one in their results and discussion. So here I have provided my client the discussion. So they need to put a table like this. Again, it's up to your school, but me, I have given and I have presented on how to discuss this one. So you will have the table which have 7 columns and 3 rows. Need to have the pretest and post-test here, the mean, and then the standard deviation, the t value, the parity test value, the df, the degree of freedom, and we have the p value. This is actually less than 0.001 or just 0. So highly significant. So since the p value is less than 0.001, so therefore it is highly significant. Almost 0, okay? So if it is almost 0, therefore, there is a significant difference between the two, the pretest and the post-test. So the mean is taken from here, copy here, post-test here, the mean, the standard deviation here, and then also the post-test here. The p-value is taken from here, the statistics. So you need to paste it here, and then the df, the degree of freedom, this one, 23. Degrees of freedom is taken by the number of paired, and then minus 1, let's see. Here, we have 24, and then minus 1, that is the degrees of freedom. And then this is how you will discuss. The results of the paired t-test in testing the significant difference between pre and post-test are shown in table above. So it depends on your results and discussion how many tables you have read. The pre-test has a mean score of 2.75 with a standard deviation of 1.39. while the post-test has a mean score of 6.92 with a standard deviation of 1.59. Here, the post-test mean is significantly greater than the pre-test mean, with 0.001 indicating that threshold of significance is less than 0.01. Thus, there is sufficient data to establish that at 1% level of significance, the intervention, so what is your intervention? Is it flashing of flashcards or whatever you have done, considerably enhance the student scores and is effective. Okay, so that's how you will use the paired t-test. So thank you, and once again, thank you for watching my video. Don't forget to like and subscribe.